Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. How is everyone? So I hope everyone is doing well after our test. So inshallah, today I'll just continue with our discussion on some applications of the derivative. So today we're gonna basically look at the application of chain rule, inshallah. So let me just try to get the slides. So I believe this is where. So let's just. Let us just try to have a brief review of what we have. I think we have started this topic last week. So this is all about basically chain rule is another shortcut where it can save us a lot of time, especially when we are dealing with composite functions. So what are the composite functions? So composite functions are basically functions that are a combination of several functions. Okay, for instance, in this example, we have our function m of x, which is x squared plus 4. Okay, and this whole thing is to the power of 3. As you can see, this is actually a combination of a quadratic function where we have this this is our quadratic function x squared, and then this whole term, okay, is a cubic function to the power of 3. Okay, so we can basically separate this into two functions. Okay, so this is a combination of a cubic function u cube and the quadratic function x squared plus 4. So let's say you want to separate this into two functions, two separate functions. So the first one is y equals u to the power of 3, where u, which we have defined to be all the terms inside the bracket, x squared plus 4. So we can express this y, as a function of x, where y is a function of u, because u, okay, is we have defined u to be x squared plus 4. Okay, so this is how we can basically express y to be a function of x. Now this m is what we term as the composite functions, because it consists of two functions, f and g. As you can see here, g is nested. Okay, it's nested inside f. Okay, so these two are composite. They make up the composite functions. Okay, um, so this is just an application how we can solve. We can find the derivative of a composite function. So if we have this. Okay, so let f of u equals e to the power of u and gx equals negative 3x. So we are asked to find, okay, so how can we find f of gx and g of fx? So what you need to do is that you simply need to replace. For instance, in this, okay, in this term, u is the independent variable, u here. So whatever we have in this bracket, you need to replace u with gx, where gx has been defined as negative 3x. So we simply replace negative 3x, okay, here. We simply replace u here, this u with negative 3x. While for g f of x, so x here is the independent variable. So this x, now we need to replace this with the whole function, the whole f of x. So f of x is e to the power of u. So we have replaced that with, so we replace this whole x with e to the power of u. Okay, e to the power of u. And how can we separate this? Can we separate this function into as a composite of two more simple functions? Of course we can. Okay, so this y, we can first of all write this, we make this whole thing to be u. Okay, we make this whole thing, the power of e to be u. So we have f u equals 100 e to the power of u, and then we simplify u to be 0.04x. So when we have this, so these two functions, okay, they are the components of this composite function. Okay, now let's try this. So what do we have? So here we can rewrite this. If you, I mean, like, we can simplify this. So this can be, I mean, I always like to basically rewrite for, okay, doesn't wanna, okay. So we have 4 minus x square, and this is to the power of half. Now, this is basically a composite function where we have two separate functions. So now we can actually simplify this. So let's try to call this whole thing to be u, where now we have y. So this then would simplify to u to the power of half, where, so this is our f of u, where u then equals 4 minus x squared. Okay, okay, so this is our g of x. Okay, this is how we define the composite function. Okay, um, so now let's try to do some apply the concept of derivative with when we have composite function. So the first formula is to apply the power rule. So this is just to recall, this is the power rule. So if we have a composite function, we can apply the power rule. Okay, when our composite function is in this form, okay, is in the form of a power function, okay, in the form of a power function. Um, so this is how we apply. So we simply, just like the power rule, so the general power rule is that when we simply take the power n, we put it to the front, okay, we multiply that with the original function, and then we have, similar to the power rule, we have to subtract 1 from the power, but don't forget, we also need to find the derivative, okay, of the function ux inside. Okay, so here we have u prime of x, and we have to multiply this with the original function. So this whole thing would be the derivative of this composite function. Okay, so now let's just try to find this derivative. So so this is, we can, you should be able to see that this is a composite function. So where we have, so let's try to define this. So so the whole thing in the bracket. So let's define that to be u equals g of x equals 3x plus 1. And then we have y equals f of u equals u to the power of 4. So this is how we define the composite function. So now we want to apply the derivative, the general power rule. So this is to the power of 4. Okay, so this is to the power of 4. So basically, if we were to apply the general power rule, x, so we're going to have, so we bring this 4 to the front, 4, and then don't forget everything inside the bracket, and then 4 minus 1 is 3, and don't forget to multiply. We have to differentiate the term inside the bracket, which is 3. So this should give us 4 multiplied by 3 is 12, 3x plus 1 to the power of 3. Okay, so if you are not comfortable with this, you can do them separately. I mean, you can do them one by one. Here we have f prime is 4, okay, for u3, and this is u prime equals 3. So then what we need to do is we simply need to multiply these two together, and don't forget to substitute u with 3x plus 1. Okay, this is our answer. Should be simple. Okay, another example here. Okay, so find the derivative. So here, so what should we do? So we have, so let's say this is, we're going to define u, the whole thing here, yeah, to be our composite function u. Or let's say if you already, used to this, we can do this directly, isn't it? So what is y prime? So 7, we bring 7 to the front, rewrite everything in the bracket, and then 7 minus 1 is to the power of 6, multiply with, how do we differentiate the thing in the bracket? So we have 3x squared. So multiply this together, going to give us 7 multiplied by 3 is 21 x squared, everything in the bracket, x squared plus x cubed plus 4 to the power of 6. So this is our answer. Okay. I'm just doing the kind of a shortcut way. Or you can do this one by one. Okay. Next example. So now this is we have one, and this is a rational function, but we can rewrite this. So we have, how do we rewrite this? If you want to apply the power rule rather than using the quotient rule, we have to bring this denominator to become the numerator. So we can rewrite this function. So this is, let's say this is f of t equals, we have t squared plus t then plus 4 to the power of negative 3. Okay, negative 3. So from here, you can see that this is a composite function, right? This is my u, u to the power of negative 3. So now what is my f prime of t? So this is negative 3. So I can bring negative t to the front. So rewrite everything inside the bracket as it is. So negative 3 minus 1 is negative 4. And now don't forget to differentiate all the term inside the bracket. So this will give us bracket 2t plus 1. Okay. So can we simplify this? What do you think? Of course, we can simplify this, but in exam, it is okay to leave this like this. Okay. If you want to rewrite it in a more elegant way, you can put this back into the denominator because it is to the power of negative 4 like this. Okay. Okay. So the next application of this composite function is where we can apply the chain rule. Okay, the chain rule. So how do we apply the chain rule? So the chain rule basically says that if we have a composite function, okay, which is nested, so Ix is nested inside E, then if you want to differentiate, if you want to find the derivative of this composite function, so we simply, first of all, we differentiate E with respect to Ix, because X is a variable inside, okay, inside Ex. And then we have to again differentiate, and we need to find the derivative of I with respect to X, provided that both of these are differentiable. Okay, we can find their derivative. That's what we have done before. Okay, all the thing inside here, we have to also find their derivative. Okay, we also need to find their derivative. Okay, so this is a different notation for the application of the chain rule. So let's have a look at this example. Okay, if we have a composite function, okay, like this, so how do we find the derivative? What is m prime of x? Now, this is 3 to the power of 2. So we can bring this 3 to the power of 2, everything inside the bracket as it is first, and then 3 over 2 minus 1. So 3 over 2 minus 2 over 2 will give us half. And then don't forget, we also need to differentiate the thing inside the bracket. So this will give us 6, right? 6x. Okay, so I want to write this in a more elegant way. So 6 multiplied by 3 divided by 2. So this will give us 9, right? So 9x, we have px squared plus 1 of half. Okay, so this is the direct way of doing the finding the derivative, or you can separate them one by one. Okay, I'm just I don't know, I kind of because this seems to be pretty much simple, so we can do this directly, or you can do them one by one, where first you you substitute or you put u to represent the thing inside the bracket, where we have u to the power of 3 over 2, and we have ix here, because this is a composite function. Okay, this is a composite function, and we differentiate them. We differentiate them each one by one. So by the chain rule, you need to memorize the formula here. So where we first take, we first put this 3 over 2, okay, and then we put the original function, okay, to the power. You replace this u with this, the thing inside the bracket, because u is our ix, and then we got the answer. Okay, we also need to multiply with this, the derivative of I of x. Okay. Okay, another example. Okay, another example. Now, this is an exponential function. Okay, exponential function. Now, let's try to do that. So let's say this is, so we're gonna define this to be, so our e. Okay, sorry, our e of u equals e to the power of u, and our I of x would equals all the thing, okay, to x cubed plus 5, right? So this is basically our u, right? E to the power of u. So now if you were to differentiate this e prime of u with respect to u, we're going to have e to the power of u itself. And what about this u prime? Okay, I prime x equals 6x to the power of 2. Okay, 6x to the power of 2. Now, if you were to combine this, okay, m prime of x would give us, so e to the power of u, okay, but this is now x, so we rewrite the whole thing, x plus 5, okay, and then differentiate. So I prime of x, so we have to multiply this with 6x squared. Okay, so now rearrange things to make it, to make it looks better. E to x plus 5. Okay, okay, this answer, they are simple, right? You just need to be careful. If you're not sure, you do them one by one. Okay. If you are okay, then you can just do it directly like this. Okay. Now, this example, I'm gonna basically leave this to you. Okay. So please do it on your own. Make sure you know, okay, how to find this. Okay. You simply need to replace the whole thing inside the bracket with u. Okay, and then this whole thing inside the bracket would be your I of x. Okay, so when you differentiate them one by one, so this, when you differentiate with respect to u, we're gonna have 1 over u, right? This is natural log of u. So when we differentiate this with respect to u, it's going to be 1 over u. And this is going to be 2x minus 4. Okay, 2x minus 4. So when we apply the chain rule, it's going to be what? It's going to be, so what will it be? So we rewrite. So m prime, so let me just write here so that I won't, m prime of x equals, so we have 1 over u. So what is our u? So 1 over, rewrite the whole thing, x squared minus 4x plus 2. Okay, and then multiply with this, I prime of x, which we have, put in bracket, 2x minus 4. Okay, so rearranging them, we have 2x minus 4 over x squared minus 4x plus 2. Okay, so you can leave this answer like this, right? Okay, simple, right? Okay, so this is basically the chain rule. Okay, generalizes the basic derivative rules. Okay, where whenever we have a function, okay, which is to the power of n, So the derivative of this function, we simply take, okay, we simply apply the simple power rule. We bring the power to the front, we subtract 1 from the power, and then we have to multiply, okay, the term with the derivative of the function itself, okay, of the function itself. Okay. So similarly for a natural log function, when we find the derivative, we simply rewrite, okay, 1 over fx. This is by applying the simple derivative of the natural log rule, okay, where if we have natural log of x, if this is our f of x, so the derivative f prime of x would equals 1 over x. So we put the whole function in the denominator, and we need to multiply this with f prime of x, the derivative of the function itself. I mean, if you look here, what is the derivative of x? It is 1. So actually we apply the general derivative rule even here, okay, even here. But the this becomes 1 over x because the derivative of x is 1, okay, it's 1 itself, okay. And this is for the exponential function, okay. So e to the power of f of x, so we have e to the power of f of x itself multiply with, we have to find the derivative of the power of the exponent, okay. um, Examples, more examples. So here we have e to the power of 2x. So how do you find this? D over dx. So this becomes, we rewrite the whole thing itself, multiply with, we have to find the derivative of 2 of x, which is 2. What about this? So this would be 1 over x squared plus 9 multiply with, so what is the derivative of the thing, the term inside the bracket? It is 2x. Okay, simple, right? Should be. Okay. Next, okay, so now we have this function. So how do we find the derivative of this one? So this is a composite function. So let's just try to do it one by one. So we have u equals 1 plus ex squared. Okay, okay, now and so this is our I of x. So what is I prime of x? This would be e x squared multiply with, so how do we find the derivative of this? I mean, this is 0, right? So derivative of 1 is 0. Derivative of e to the power of x to the power of 2. So this will bring us e to the power of x to the power of 2 itself multiply with, we need to find the derivative of the power. So x squared will give us 2x. Okay, 2x. And what about our this original function? So this is let's say f of u equals u cubed. So f prime of u equals 3u to the power of 2. So combining all this, so we can find the derivative. The derivative, so the derivative, the d of x, 1 plus ex squared cube equals, so we have 3, and then we have u. So we replace u with the original function, the original term, ex squared, okay, to the power of 2 multiply with this. So we have 2x ex squared. So you can leave this answer like that. Okay. Or you can rewrite them in a more elegant way. Okay, in a more elegant way. So here we have 3 multiplied by 2. So this is 6x ex squared 1 plus ex squared. Okay, so this is, and that's basically it for the application of the chain rule. Okay, so I hope with that explanation should be clear to you, and please try to do a lot of questions to familiarize yourself with the application of chain rule, and especially when it is being combined with all the other rule, the power rule, the natural log rule, as well as the exponential rule. Okay, so that's all for now. Inshallah, we'll continue with some other topics. Inshallah. Assalamualaikum warahmatullahi wabarakatuh.